Okay guys, welcome back. So in the last video I explained to you about three examples actually. Three examples in which we had to find inequalities. Those were just reminders of the basic concepts of inequalities. I explained to you about inequalities in one of my previous videos, actually a series of videos on inequalities. So the last video was about a concept, actually a video to remind you as examples, as a revision of the basic theories of inequalities. So in this video I'll be talking about some complex inequalities in which we have to do two or more inequalities in order to solve for some algebraic term. So say that if you are given something like this, so say minus 3 is less than or equal to 2x plus 5 is greater than 8, greater than 8. Right? Simple like this. So if you are given something like this, so as I mentioned in my video on the basic concepts, what you have to do here? What you have to do here is that if you are given something like this, first of all, you need to identify. You need to identify that there are two inequalities here. So this is the first inequality. Minus 3 is greater than 2x plus, minus 3 is greater than, less than or equal to 2x plus 5. And the second inequality is 2x plus 5 is less than 8. So since there are two inequalities, you can't solve it this way. You have to break this into two parts. So I will break this into two parts. One and two parts. So my first part will be minus 3 is less than or equal to 2x plus 5. Right? So that is about this part. About this part. And my second part will be something like this. Second part will be this one. Second part will be this one. So that is 2x plus 5 is less than 8. Now I have two inequalities. I need to solve for those, and I have to take the common range, as I mentioned in my previous videos. Now, first of all, before finding the common range and the other things that you are needed to find the final solution, I have to solve these two equations. So first of all, I'll take the equation on the left. So since minus 3 is less than or equal to 2x plus 5, so in order to solve for x, what I will do here is to isolate x. Isolate x. So to isolate x, I need to remove this positive 5. So to remove this positive 5, what I will do is that I have to subtract 5. So if I subtract 5 from both sides, plus 5 minus 5 will make the right hand side limited to 2x, and the left hand side will be of some value. So what I will do is that in order to isolate x, I will subtract 5 from both sides. So if I subtract 5 from minus 3, what I will get here is minus 3 minus 5 is minus 8. Minus 8. And that is less than or equal to 2x plus 5 minus 5 is equal to 2x. Now actually I am dividing by a positive integer. So I will not change the sign of this inequality. So dividing by 2, I will get here minus 4 is less than or equal to x. So this is one solution. This is one solution for x. So when I take the right hand, the inequality on the right hand side, what I will get is 2x plus 5 is less than 8. So similarly here, what I will do is that in order to isolate x, or a coefficient of, or a multiple of, integer multiple of x, or some multiple of x, what I will do here is that I have to take this 5 out, right? Eliminate this 5 from the left hand side. So to eliminate this 5, what I will do is, since this is positive 5, what I will do is I will subtract 5 from both sides. So if I subtract 5 from the left side, what I will get is 2x plus 5 minus 5, which is 2x. And when I subtract 5, I will not change the sign, right? Sign of the inequality. So that will be the same, less than 8 minus 5 is 3. Now in order to take a solution for x, what I will do is I have to completely isolate x. Completely isolate x even from the integer part, integer coefficient of x. So what I will do is I will divide both sides by 2. So 2x divided by 2 will be x. So I can isolate x in the left side and I will get some value in the right hand side. Since I am dividing it by positive 2, I will not change the sign of this inequality. So the sign of this inequality will be the same, or will remain the same. So this will be x. 2 divided by 2 is 1, so that will multiply by x is x, 3 divided by 2 is 1.5. So x is less than 1.5. So this is the second solution. So I have two solutions. Now if I draw these two solutions on a number line, like this, so I take x here and x here. So my first solution, I'm drawing the first solution here and the second solution here, and then I'll draw the common solution somewhere here. So my first solution is that x is greater than or equal to minus 4, right? X is greater than or equal to minus 4. So first of all, in order to find the common range, I have to take some point here and make it minus 4. Since x is greater than or equal, I have to make it a colored circle. And since x is greater than or equal, I have to take the range that is greater than minus 4. And I don't have, now I have some left limit here, but I don't have right limit. So my right limit will be positive infinity. So the range of this inequality that satisfies the first solution will be like this, right? And for the second inequality, x is less than 1.5. So in order to find the range, first of all I have to take some point as 1.5 here. Since x is only less than 1.5, I have to, and since there is no equal mark, I have to draw only an uncolored circle. Since x is less than 1.5, what I will do is that I have a right limit here, I have no left limit, because I am decreasing the values of x here. So I don't have a left limit, so my left limit will be minus infinity, and my range of data, or the range of value that I will satisfy this equation, this inequality will be like this. Right? So these are the two number lines that denote these two inequalities. So in order to find the solution that satisfies both these inequalities, now I don't want the solution for this inequality, not the solution for this inequality. I want the solution for this, the basic inequality here. Now what I did was I divided this inequality into two parts, and I found the solution. But I found the solutions only for the inequalities that I divided here. But the question is asking the solution for this inequality. So to find this inequality, since I divided this into two parts, finally if I merge these two parts up here, the solutions of these both these inequalities should satisfy this one, or the solution common to both these, the solution common, right? The solution common to both these inequalities, right? Solution common to both these inequalities, or both these value ranges, will satisfy this one. So I have to draw. So in order to find the common range, what I have to do is that I have to draw both these inequalities, both these data ranges or the value ranges within a single number line, and see what happens when I draw them. So if I have some inequality here x, I will get minus 4 here, because minus 4 is greater than 1.5. I have to draw minus 4 first, and then 1.5 here. So from this data range, you can say that this is greater than minus 4. So I'll draw the same. So it will be something like this. And from this one, what I can say is that this is 1.5. I have to color this, and this is going to minus infinity. So something like this, right? Something like this. So the data range that is common to both these inequalities, or to the main equality, is this range from here to here. Now you can't actually equal it to 1.5, because we have taken only the less than sign, not the less than or equal. So my right hand limit will just touch the 1.5 line, but will be equal, but it will be equal to minus 4. So the data range that is common to both these inequalities is this range, and that satisfies this one. Minus 4 is x is greater than or equal to minus 4, but is less than 1.5. or if you are denoting from the set notation, it will be something like this. Now since it is equal, you have to put a square bracket here, minus 4, separate it by a comma, and take the right limit here. Since this is not equal, you have to draw a curly bracket. So the ranges that will between minus 4 and 1.5 are the solutions of this main equation, that is the question or the solution that is being asked. So those are that is an example in which we have to solve complex inequalities. So in the next video I will be talking about more complex topics on inequalities. See you then.